Now here we have cam terminology. Cam terminology means there would be some basic definitions or basic terms which would be used in cams and followers. That is, while drawing the cam profile, we would be requiring some of the terms which we need to understand regarding cams and follower. Now here the example which I have given, in this we have a roller follower which, and because of that there is a cam profile generated. Means in case of cams and followers, if we see that cam is a rotating machine element as per the definition, and follower will follow the motion of the cam. But when we are drawing the cam profile, we are assuming, it is a very important part, that the assumption is the cam is stationary, cam is fixed, and the follower is moving around the cam. And when the cam is fixed and the follower is moving around the cam, then the profile which we are generating, that would be called as cam profile. Next, here we have base circle. Base circle is the minimum circle. Which can be drawn to the cam profile. The least value of the circle which can be drawn. Next, we can say that from the center of cam to the center of the roller follower, if we draw a circle, which I have drawn in red color here, it is called as the prime circle. That is from the center of the cam to the center of the roller. If we are drawing a circle, that would be called as prime circle. Next, we have the pitch curve. This pitch curve is generated, that is when we have outstroke, because if we see in case of cam, we have 4 different strokes. Those are called as theta O, that is outstroke, theta R, that is return stroke, theta D1, that is dwell period for the first time, and theta D2, dwell period for the second time. It means the 360-degree rotation of cam is divided into these 4 rotations, and these 4 rotations, they can be same, they can be different, the values can change as per the type of problem. So theta O is called as outstroke, theta R, it is called as return stroke, theta D1, it is dwell, we can say dwell period, and again theta D2 is another dwell period. So we can say that the 360-degree rotation of cam, it is divided into 4 parts. These 4 parts, they may be equal, they may not be equal, the values may go on changing. So here I can see that from the center of the cam, I have denoted theta O. It means it is outstroke for this much amount of angle. Next, here I have denoted theta R. It means this is the return stroke. Theta D1 is the dwell period first. Theta D2 is the dwell period 2. Now, when we are talking about the dwell period, in that case, the cam and follower, they does not move. That is, follower is not moving up and down at the same time. What happens? Even though the cam is rotating, cam will rotate during the dwell period, but follower will remain in its position. So here we have the dwell period from here to here, that is, I can say that from point number, after point number 6 to point number 7, here we have dwell period, that is cam will rotate but follower will remain at its position. Similarly, we have another dwell period, that is here. Next, when it is outstroke, during that case the cam will rise, that is the cam will rise and the follower will move up. So here in this case we are assuming the cam is stationary, so follower will move up. And then theta outstroke, this would be in terms of an angle. That angle we need to divide, and then there is a procedure by which we get the center of the circles. After getting the centers, we will take the radius equal to the radius of the roller, and we will draw just small arc, not complete circle, just small arc. And then similarly we will divide the angle for return stroke and mark the centers. After marking the centers, we would be taking the radius and drawing small arc here, and finally when we join the base tangents, of these arc we would be getting a profile, and that profile is called as cam profile. So I hope you all might have understood the terminologies here which is related to cams and followers, and these terminologies are very important to solve any problem related to cam and follower. Next, let me classify the various follower motions because follower motion are necessary to solve any kind of problem. So the next heading is types of motion of follower. So based on the types of motion we have uniform velocity, the first kind of motion. It is called as uniform velocity or uniform motion. The second one is SHM or simple harmonic motion. Next, we have uniform acceleration and retardation. And the last one is cycloidal motion. So, as I have told before, that in case of cams and followers, our assumption while drawing the cam profile is that cam is stationary and the follower will move around the cam, like we have seen in the terminology part. Cam will be stationary and the follower will move around the cam. So the movement of the follower, that we are classifying it into four parts. It is uniform velocity or uniform motion. It can be SHM or simple harmonic motion, uniform acceleration and retardation, or cycloidal motion. Now out of these four, only the first three they are important. Cycloidal motion, it is very rare because cycloidal motion, the cam profile and the follower, the motion, this motion is quite complex. So we only prefer the above three kinds of motion. So we will see each one of them in detail now. The first one is uniform velocity. I will draw the displacement diagram for this. I'll explain what I have drawn here. So this is the diagram which I am having for uniform velocity. So if in the problem is given, it is given that the follower is moving during the rise period or outstroke, we can say that it is moving with uniform velocity. So here this angle, this would be called as outstroke, denoted by theta O. Next, between 6 to 7 there will be dwell, theta D1. Then again after outstroke it will be return stroke, theta R, and then it will be the second dwell period. So when in the question they have mentioned that the follower is moving with uniform velocity and returning with uniform velocity, then the diagram would be such. Here this vertical height, it indicates the stroke or lift. Stroke or lift means the maximum distance traveled by the follower in the lowermost position to the topmost position. So if the lift is given, that we will plot on the vertical axis. So outstroke will be divided into equal number of parts as the stroke length, and then we will pass the first division from horizontal line, and then vertical line, we will get first point. Next, second division here, we will get the second point. Third division, fourth division, fifth, and when we join all these points, we would get an inclined line here, and this inclined line indicates the motion of the follower, that is follower is moving up. And during the fall, again same thing we would be doing. So finally again we would be getting the motion in the downward direction if we are plotting each of the points, that is point number 8, point 9, point 10, point 11, and finally point number 12. So here we would be again be getting a downward direction, that is it is the return of the follower. In outstroke, the follower would be moving upward, that is if we consider the knife edge follower, then this knife edge follower would be here at the first location, then it would be moving up, then again up, and finally we would be reaching up till here. So this is the meaning of the diagram, that during outstroke the follower is moving up, and during the return stroke it will fall down, and finally it will dwell. So this is the meaning of the diagram of uniform velocity, where outstroke is the distance moved by the follower when it is moving up, dwell it will remain at the same position even though cam rotates, and fall, that is return stroke, when the follower would be moving down. So this is for uniform velocity. Next, for simple harmonic motion, SHM, also called as simple harmonic motion. Here again the lift will be plotted on the vertical line, and then we would be marking outstroke, dwell, return stroke, and second dwell, I'll write the terms here, outstroke, dwell, that is the first dwell, then return stroke, and second dwell period. Outstroke would be denoted by theta O, dwell would be theta D1, return stroke would be theta R, and dwell would be again theta D2. So now here we have the vertical distance as the lift or stroke, outstroke, dwell, return stroke, and dwell have been marked. If it is simple harmonic motion, then corresponding to the stroke we will take the center of the stroke, and then we are going to draw a semicircle here. This is done only in case of SHM. We will draw a semicircle and divide it into 6 equal parts. After dividing it into 6 equal parts, we will again divide the outstroke also into 6 equal parts, and return stroke also into 6 equal parts. I will write the naming here. So now I will plot horizontal point number 1 from here, vertical point 1, similarly point 2, point 3, point 4, 0.5 and 0.6 is here. Now for simple harmonic motion, I will have to join the points in such a way that we are getting a curve. So this indicates simple harmonic motion, the follower is following, and similarly it would be simple harmonic motion during fall as well. So I'll join the points here. So during the fall also it is simple harmonic motion. So such motion is possible if it is given that the follower is following SHM, then we would be drawing the displacement diagram in such a way. With this we complete SHM.